In question number 7, we have to express 5 sine x plus 1 upon 6 pi minus 4 cos x in the form r sine x minus alpha. We have to state the exact value of r and give the value of alpha correct to 3 decimal places. Now, to in the first step, we'll have to expand sine of x plus 1 upon 6 pi. The formula, it's given in the formula sheet as well. That's sine a cos b plus cos a sine b. So we can write this as 5 and bracket sine x cos 1 upon 6 pi plus cos x sine of 1 upon 6 pi minus 4 cos x. Now, multiplying, we'll get 5 sine and cos of 1 upon 6 pi. If we substitute this in the calculator, that is equals to root 3 by 2. So we'll get 5 sine or 5 into root 3 by 2 first. So 5 root 3 by 2 sine x, and sine 1 upon 6 pi is half. So that will be 5 into half will be 5 upon 2 cos of x minus 4 cos of x. And we can just write it as c as well to save our time. Now, taking the LCM over here, we'll multiply this by 2. We'll get 5 root 3 upon 2 sine. And this will become plus 5 minus 8 would be minus 3. So this will become minus 3 upon 2 minus 3 upon 2 cos. Now, once we have our expression in this form, we know we can find r that is equals to a squared plus b squared. So if we have a sine of x plus b cos of x, r is equals to a square plus b square. For revision, you can check the lessons on each of these topics, and you will get to know the basics behind how to convert or how to expand the expression, or to write a sin x plus b cos x in the form r. So we write it as r of sine of x plus alpha or minus alpha, and similarly r of cos x plus minus alpha. So r would be equals to square root of 5 root 3 upon 2 whole squared plus b is minus 3 by 2, but as it's a whole square, it will cancel out. Simplifying this, we'll get, so 5 square is 25 into root 3 square is 3 upon 4 plus this will become 9 upon 4. So 75 plus 9, that would be equals to 84 upon 4 square root. 84 upon 4 is root of 21. Now, once we have the value of r, we also need the value of alpha over here. So alpha would be equals to tan inverse of b upon a. The b value is minus 3 by 2. So that now what we also know is this. So this is minus 3 by 2 or minus 1.5 divided by 5 root 3 upon 2. Substituting this in the calculator. So, and making sure our calculator is in radian mode. So we'll get shift tan inverse of minus 1.5, and then we divide it by, in the denominator we have 5 root 3, and this, okay, so there's also, it is 5 root 3 divided by 2, and the answer is minus 0.333. So alpha would be equals to minus 0.333. It is 0.3334, but we have to give it in 3 decimal places, so that would be minus 0.333. And as we have to give this alpha, well, normally we do not use a negative sign over here, so we'll just give the positive value over here. So the final value of alpha would be is equals to 0.333, as we already have a negative sign over here. So the final answer would be root 21 into, and this would be sine of x minus 0.333. Now in part B, it says, hence solve the equation 5 sine of 2 theta plus 1 upon 6 pi minus 4 cos 2 theta is equals to root 7 from 0 theta is 0 to pi. Now we know that this expression can be converted to this form, but the only difference we have to observe over here is that this is 2 theta over here, and it was just x or theta over here. So we'll just change the expression, write it as root 21 sine of, and instead of x, we will write 2x. So for this whole expression, we'll write 2x minus 0.333 equals to root of 7. So for in the first step, we'll bring root 21 on the other side. We'll get sine of 2x minus 0.333 equals to root 7 upon 21. That would be equals to root 1 upon 3. And then 2x minus 0.333 would be equals to sine inverse of root of 1 upon 3. Substituting this in the calculator. So sine inverse of root 1 over 3, that is coming out as 0.6154. So we'll get 2x minus 0.333 equals to 0.6154. Now we have to be within 0 and pi over here. So, and as it's a square root, so we'll have both the positive and negative quadrant answers. So we'll make 0.6154 in the first quadrant. We'll make 0.6154 in the second quadrant as well. We can make it on the third and the fourth as well, as it's a square root. So we'll make it in positive and the negative quadrants. We also have to take in consideration that it's 2x, so we'll have to add all of the answers by 2 pi. But as the limit of theta is only between 0 and pi, we can just use these four values. So we'll get 2x is equals to 0.6154 plus 0.333, and then we divide by 2. So plus 0.333 divided by 2, we get 0.474. 2, and as to three significant figures, so this answer will be 474 only. And then our second answer would be 2x equals to 0. So first of all, this angle would be pi minus 0.6154. So pi minus 0.6154, that's equals to 2.526. So 2.526 plus 0.333, and then we divide by 2. So plus 0.333 divided by 2, we get 1.429. And to three significant figures, that would be equals to x is equals to 1.43. And then let's take the third answer as well. And if it comes within pi, that will also be part of the answer. So now this total angle would become pi plus 0.6154. So 3.142 plus 0.6154. And then we add 0.333, and then we divide by 2. And the answer is coming to 0.054. Now, one thing to clear up over here is, and I had to check the answer out as well, and the only two answers were x equals to 0.474 and x equals to 1.43. And that was because initially in the question, the R value was also positive root 21, and this was also a positive value of root 7. Unless we whole square or whole take the square root of the equation, only in that case we will be considering the negative signs. As in this case, it was already given as root 7 and not plus minus root 7. So we'll only consider the positive values, and we'll only have these two answers over here. Now, if in a question you square root both the sides, in that case, you will have to take the negative signs as well for the negative quadrants. But in this case, we'll only take the positive values of sign, and the final answers will be x equals to 0.474 and 1.43.